Okay, today's lesson, we're going to start on section 9.3, reactions in aqueous solutions. We're going to describe those aqueous solution, what that is, write complete ionic and net ionic equations for chemical reactions in aqueous solutions, and predict whether the reactions to all solutions produce a precipitate, water, or a gas. Okay, so the main solution is a uniform substance that might contain the things that are dissolved in it. Could be solids, liquids, or gases. I'm going to go over the vocabulary here, what an aqueous solution is, the solute, the solvent, complete ionic equations, separate ionic equations, and double replacement reactions always occur in these aqueous solutions, if they occur at all, and they produce these three things, or more than one of them. They produce water, precipitates, water, or gases. And that, of course, is the main idea here. Aqueous solution contains one or more dissolved substances, and the things that are dissolved in the solution or dissolved in the water are called the solutes. And how can you tell which one's a solvent, which one's a solute? Most of the time it's pretty obvious, but the solvent is always the most plentiful substance in a solution. And sometimes, most of the time water in our chemistry labs, chemistry class will be the solvent. And water is always the solvent in aqueous solutions. There are many possible solutes, many things dissolve in water: sugar and alcohol, salt, table salt, that dissolve in there. Two they point out here, sugar and alcohol, are not ionic compounds, they're molecular compounds that dissolve in water. So molecular compounds, they stay together as a molecule, but they still dissolve in water, whereas an ionic compound breaks apart. The ions break apart and dissolves in water. And we'll get to this more when we do the chapter on acids, but compounds that produce hydrogen ions in aqueous solutions are called acids. So all the acids break apart and produce those hydrogen ions. And like I just said, compounds can also be solutes in aqueous solutions, and often are. And when ionic compounds dissolve in water, they undergo a process called dissociation. Okay, so dissociation means that the ions split apart. So for example, if you have NaCl in water, that is going to split apart to be a sodium cation and a chlorine anion in water. When it's AQ, that's what it means. It's split into these two ions. When two solutions that contain ions as solutes are combined, the ions might react. So this is where you have two aqueous solutions with different things dissolved in them, could combine and react. And if they do react, it's always going to be a double displacement reaction. Okay, so we talked about double displacement reactions. Two things trade places. The three products that can be formed are precipitates, water, or gases. Aqueous, now they go through a specific example here, the aqueous solution of sodium hydroxide. So sodium hydroxide is this compound here, NaOH, and copper 2 chloride. We did my little lab demo I did involved copper 2 chloride. So it's copper and 2 chlorines. And then it reacts to form sodium chloride, which is just table salt, and it's aqueous, which means that's dissolved in the water. And actually those two ions, the Na and the Cl, are disassociated in that solution. And then we get copper hydroxide, copper 2 hydroxide, which is a solid. The ionic equations show when we talk about ionic equations, then instead of writing an equation like this, we're going to write an equation that shows all the ions in solution. So in this part, this breaks apart to form two ions. This is two ions. Everything, all four of these compounds are ionic except the last one. So it looks like this. we have before on the reaction side, we've got 2 sodium atoms, 2 cations plus floating around, 2 hydroxide polyatomic molecules floating around. The copper and the chlorine are also floating around as ions, each in their own separate container, right? That's what it means here. They're both, one's dissolved in one beaker, we'll say, and the other's dissolved in the other beaker. And then we throw them together, and what comes out of it is what we see. What comes out of it is the copper hydroxide. That's what we see as a solid precipitate come out of it. The sodium and the chlorine stay in solution, right? They're still ions. They were ions before. The sodium and the chlorine were both ions before, and now they're both ions afterwards. Okay, so we separate these ions that go in these reactions into ions that actually take part in the reaction, and then the other ones are called spectator ions. So in that last example, the spectator ions were the sodium and the chlorine. So if we write the net ionic equation, so in the example we had there, we had the ions that did not participate were the 2 sodium ions before, 2Cl afterwards, and they were still ions after the experiment. They were still ions after it happened, right? So they didn't do anything. They just were floating around before in solution. Now they're floating around before after solution. So that's why these, in this reaction they just did, the spectator ions would be the sodium and the chlorine. The hydroxide combined with the copper to form copper hydroxide. That's the net ionic equation. These are the ions that actually form together to come to be something other than some ionic thing in solution. That's a solid that precipitated out. That's a compound that formed, and it just didn't stay in solution like the sodium and the chlorine did. Some reactions, of course, produce more water molecules. When that happens, then there's no evidence it's hard that a reaction has taken place. Okay, you have to very carefully measure the amount of water before and afterwards to figure out if there was a reaction. And so they have an example here of hydrogen bromine plus sodium hydroxide combined together. These two are in solution, right? It's H plus, Br minus, Na plus, OH minus are in solution. They combine together to form water. So this OH and this H combine to form a water molecule. The Na and the Br are still molecules in solution. So they would be without the spectator ions, of the hydrogen and the bromine and the sodium, then it would look like this, where the hydrogen and the hydroxide react to form water. Gases are commonly produced: carbon dioxide, hydrogen cyanide, and hydrogen sulfide. This reaction that we have here takes hydrogen iodide, lithium sulfide, and it produces hydrogen sulfide gas. That's this compound here. And the lithium and the iodine stay in solution. Okay, so these, the lithium and the iodine, are the spectator ions in this equation, in this part. And if we were writing the net ionic equation, write the net ionic equation. I'll write it for you. The net ionic equation here would be the things that the hydrogen, the 2H, and the 2 H's plus the sulfur minus 2 form H2 gas as a gas. That's the net ionic equation. Okay, the spectator ions would have been the lithium and the iodine. Baking soda and vinegar, you can do this at home if you want. Maybe we'll do it in class as a demo, but it produces carbon. The acid in the vinegar reacts with the baking soda. This is the sodium bicarbonate is what they call this molecule. That's what's in the baking soda. This is, I don't think it's, well, I guess we'll just go with hydrochloric acid here because that's what they put. And I think that's right, actually. So it gets this hydrogen, it produces this molecule, which is hydrogen carbonate in solution and salt. Now what happens to this where you don't see, well, let's say, where are the bubbles, Mr. Albert? I don't see any gases produced here. Well, what happens right away is that this H2CO3, the hydrogen carbonate, immediately decomposes, right? When it's not, these two react and they do that, and then right away it breaks down to form a water molecule and carbon dioxide. So this is not the end all for this. This is like a first step, and then immediately the second step happens here, and it gets broken down into water and carbon dioxide. And oftentimes the reactions are combined in a single chemical reaction, and they show it here. This, it's a double displacement reaction. It starts off, and then that reaction goes to a decomposition reaction. So you have a double displacement reaction followed immediately by a decomposition reaction. And this is the reaction 1, which they had on the other slide. Reaction 2, just a little more clear, I guess, what they had there. And the combined equation looks like this, where you have the hydrochloric acid, sodium bicarbonate, and those two combine to form hydrogen carbonate, and then the hydrogen carbonate breaks down into, well, it doesn't want to follow that equation. This equation down here is better. That one's too confusing. This is what normally how you see it written in the equation. The hydrochloric acid, the bicarbonate of sodium bicarbonate, equals water, carbon dioxide, and salt. Okay, so that's why you can drink baking soda, because it's just, and that's why it bubbles, and that's why it kind of tastes salty if you ever drinking it. I doubt if you have. Okay, so I'm not going to bother with that. So that's it. That's the last part of chapter, the last section 9.3. Answer the questions on the form, and we'll see you tomorrow in class.